Okay, all right, we're in. Welcome everybody to next to live streaming. In this video live stream, what I'd like to do is cover simplifying rational expressions. And basically what we're going to do is not just like simplify a rational expression, but we are also going to apply the operations of addition, subtraction, multiplication, and division. And we'll also go ahead and investigate complex fractions. So what I am going to do is kind of work through these 8 examples on the homework, and then what I'll do is take a nice little break, and then we'll kind of get into some multiple choice type of questions, as that is a lot of times what my students will see on, test and exam and kind of stuff like that. So then I will cover those, and then that will be it for the live stream. Did I not? No, I didn't have a problem to think about. Okay, so any of your questions, guys, are welcome free. I was hoping to get this started around 3 o'clock, but I apologize. I had a call earlier that kind of went a little bit longer than expected. So, but either way, I think I'll probably go on here for about 40 minutes, 45 minutes, as long as this really is going to take. But then if I do have some extra questions, I will be more than happy to jump into the chat and see what I can do to help you guys out with your math. So, hey, Zach, hey, Mohammed, hey, Mala, hey, Francis. Glad you guys could join, and I am happy to be able to offer some math for you guys. If you are, have learned rational expressions, covering it, we're just kind of doing a miniature unit. It is something that's usually attached onto a polynomials unit in pre-calculus, but what I've found is a lot of students don't really get those detailed skills from the Algebra 2 class. So I just decided to make a little miniature unit out of it to really kind of reinforce a lot of the skills that come up in, rational expressions. So hopefully I wrote all of these problems out wrong. I don't have any typos, but we will just go ahead and check to see, and let's go ahead and get started. So the main idea when, simplifying rational expressions is to apply the division property. And the division property basically states that anytime we have a number, a variable, or an expression that is the exact same in the numerator or the denominator, meaning it's being divided by itself, it goes to 1. But the important thing with that is the division property only works when we have terms separated by multiplication, not addition or subtraction. So, for instance, like these x squareds, I can't just divide those out, and these x's, I can't just divide those out, or I can't take the 2 and divide it into the 4, because we have these terms are separated by addition and subtraction. So what we need to do is we need to rewrite it as a product, basically rewrite an expression as a product, and that process is factoring. So for all of these problems, which I'm looking at this and I'm like, man, I didn't really give myself a lot of space. We're going to want to factor and then apply the operation and then see if we can factor it again as well. And a lot of times we talked about in my class, we went over identifying the restrictions, but I'm not going to have that for this homework. I'm just going to work on applying the operations, and we will leave the restrictions alone. So in this first example here, we can see that we can definitely factor out a 2 in this numerator. So I'm going to kind of use some work to the side. So if I factor out a 2 in the numerator, I'll be left with a x squared minus a 3x plus 2. And then the denominator, I see that this is going to be, it's a quadratic, but again, I can't factor anything else common, but I know that this can be rewritten as a product of 2 binomials. So I'm going to go and get that set up, and then I'm going to go and see if I can figure out what it is. So the last 2 numbers need to multiply to give me 2, which is 2 and 1. Since it's a negative 2, that means it's going to be a difference. And since my middle term is negative, that means the larger of the 2 products has to be negative. And what I see then is, well, then I need the 3 to be times a 2. I want that to be a negative, so that gives me negative 6, and then this would be a positive 1. And I just go and check my work here real quick. 3 times x is 3x squared. 1 times negative 2 is negative 2. That's positive 1x. That's negative 6x, which gives you negative 5x. Cool, so I got that done. Now this trinomial, I can factor a little bit further. And again, you can see here 2, but it's positive, so that means it's a sum, and it's a sum of 2 negative to give you a negative term, so that's going to be negative 2 and negative 1. So let's go ahead and rewrite that as 2 times x minus 2 times x minus 1 all over a 3x plus 1 times an x minus 2. And now you can see that we have all of our terms separated by multiplication, right? So now I can apply the division property and say x minus 2 divided by x minus 2 is just 1. And so therefore 1 times all of this is just going to not matter. So therefore my final result is 2 minus x minus 1 all over 3x plus 1. Okay, and you can simplify this. Obviously, in the directions, my quiz, I'll tell students when I want that to be like simplified or in factored form. But for this lesson, because I have so many problems, I'm just going to leave it as in factored form. All right, for the next polynomial, you can see that this is being raised to the 4th power. So, but then the middle term is x squared. So I'm going to think of this as like an x squared and that as like an x. So I'm going to use substitution. You can substitute in these variables to help you factor that. So if I did this like x squared plus 5x plus 6, I see that that is factorable to x plus 3 times x plus 2. However, I need this to multiply to give me x to the 4th, so I'm just going to raise the power of the factors. So by raising the power of the factors, I will have an x squared plus 3 and an x squared plus 2. Bad 2. All right. Now, in the denominator, you can see I have 4 terms. So 4 terms, I can't use the factoring to 2 binomials as I did for a trinomial. I'm going to want to use the grouping method. So to use the grouping method, if you remember, we're just going to group the first 2 terms and then group the last 2 terms and basically see what we can factor out that they have in common. And you can see here that these 2x cubed and x squared has an x squared in common. And that's going to leave me with a 2x plus 1. And then over here, again, they have a 2 in common, a positive 2, and I factor out a positive 2, I'll get this exact same expression, which is exactly what I want. When you're factoring by grouping, what you want to do is you want to make sure that the parentheses that you're getting are exactly the same, because that's the idea. You're going to need to factor this twice. You first factor out the GCF of the first 2 groupings, and then you factor out this common factor or a common expression, which is 2x plus 1. So let's go ahead and rewrite this over here again. So this would be x squared plus 3 times an x squared plus 2. And that's all over factoring out a 2x plus 1. Oops, my bad. And I'll be left with a x squared plus 2. Well, now, again, you can see that my terms are separated. My expressions are separated by multiplication. So I can apply the division property and divide out the x plus 2, x squared plus 2's. So therefore, I'm just left with an x squared plus 3. Don't really need the parentheses, but whatever. Divided by 2x plus 1. Okay? All right, so now let's get to the next one. So now we're going to get into adding. And remember, when we're adding and subtracting fractions, we got to make sure we have common denominators. And these denominators are very similar to each other, but they're not exactly the same. So the easiest way to identify the least common denominator is just to multiply your 2 denominators. Now, that's not always the case, which we're going to find out in the next example. But in this example, that's what we'll want to do. We'll just want to multiply them. So I'm just going to say my LCD is the product of these 2. Because again, it's hard enough to identify what polynomials divide into. So if you take a polynomial and multiply it by something else, whatever that product is, your polynomial is going to divide into it because you just multiplied by it to get to it. Same thing like 3 times 4 is 12. Well, then that means 3 divides into 12, right? And the same kind of idea works here with polynomials. So to get my common denominator, I need to multiply by 2x plus 1 on this fraction. Make sure you multiply that on the top and the bottom to produce equivalent fractions. Over here, I need to multiply by 2x minus 1. Okay, now to save myself some time, you can see that now these have common denominators. So I'm going to keep the common denominator, but just now apply my numerators. So here I have 1 times 2x minus 1, which is just 2x minus 1. And then over here, though, I have x times 2x and x times 1. So that's going to give me a positive 2x squared plus x. And that's all over my common denominator, 2x minus 1 times 2x plus 1. Now, could you multiply this out to give you 4x squared minus 1? Yes, and that's perfectly fine. There's nothing wrong with that. Usually, a lot of times on the multiple choice questions and so on and so forth, we will just have that as a, just leave it in factored form. So in this case, I'm going to have a 2x squared. Let's see, a plus 3x minus 1. Now, it is important to kind of look at this and make sure that it couldn't be factorable. Because if it could be factorable, you could continue to factor this out, right? And kind of notice the process that I went here. Well, actually, I didn't factor in this case. But, I applied the operation. Now I want to see, is this factorable? Like, can I multiply this to give me a positive 3x? And the quick answer is no. So this is not going to be factorable to be able to divide this to further simplify this out. So that would be my answer there. Now, I did have a missed opportunity here, but that's okay. Actually, no, it'll still work. Okay. So in this next example, you can see they don't have common denominators. But to do the multiplying, I really do not want to just multiply these two denominators to get a common denominator. So the first thing I want to do is simplify. Always simplify first. So by simplifying this, I see that this is factorable. Let's do it this way. Still want to see what's going on. So this is factorable to a x minus 3 times an x plus 1. And now you can see that between these two denominators, they already share an x minus 3. So my least common denominator is just going to be x minus 3 times an x plus 1. Because does x minus 3, does that divide into itself? Yes. Does x minus 3 divide into that? Yes, because it's already, it divides into their x plus 1 times. So make sure before you just assume you have to multiply the denominators, check to make sure that they don't have anything already in common. So now we've identified my LCD. What's nice is I already have the LCD here, so I don't need to multiply this by anything. All I need to do is multiply over here times x plus 1. Okay. Now the nice thing here is I have a difference of two squares. So that's going to give me a x squared minus 1. And then here, the big important thing is make sure you put parentheses around this term because you are subtracting a 2x squared and you're subtracting the negative 3. Okay, so make sure you understand that that is in parentheses. A big common mistake students will do is they'll just subtract the 2x and not subtract the negative 3. And again, these are all over my common denominator, which is x minus 3 times x plus 1. Okay, and now we just combine our like terms. And we see we get a negative x squared and plus 2. That's going to go over x minus 3 times x plus 1. Sweet. All right, halfway done. Next one, multiplying. So when we're looking into multiplying, guys, same thing. You're going to want to simplify first. Then you're going to want to apply the operation, which is multiplication of fractions, which is basically multiplying numerator times numerator, denominator times denominator. And then you can go ahead and simplify from there. Now, in these examples, typically my directions are just to leave things in factored form. We don't need to simplify the result. For the adding and subtracting, I like to have the result, the numerator usually simplified. But for the multiplication, usually my directions is just leave everything in factored form. Because the main idea we want to do is, can students simplify these by factoring? So the first step is let's just simplify them. So this can be factored into x plus 1 times an x plus 2. Here I can factor out a 2x. So by factoring out a 2x, I get a x plus 3. Here I can factor this to an x minus 3 times an x plus 3, which is difference of two squares. And then this can be factored into a x plus 3 times a x plus 1. Now, the important thing to understand here is everything is now separated by multiplication. Everything is separated by multiplication. So you don't really need to, you can simplify from here. One thing you could do, which I'll show in this step, is you could just rewrite them as all one product. And I'll do this just one time because it takes some more time because I have to rewrite everything again. But I just want you to understand that basically once you get to that first point, you really are looking at the problem like this. 2x times x plus 3 times x plus 3 times x plus 1. Okay, so it's really just like one complete fraction, but everything is multiplied. Everything is multiplied by each other. So therefore, I can now apply the division property. Okay, so you can see I have an x plus 3 and x plus 3, x plus 1 and x plus 1, and that's it. So everything I'm left with here is just going to be let's write that there, let's write some equal signs. That's just going to equal a x plus 2 times an x minus 3 all over a 2x times x plus 3. And again, you could simplify, by multiplying that out, but for the sake of time and a lot of convenience, we'll just leave it in factored form. All right, so dividing, I spent a long time today talking about why we flip and reciprocate, or why we multiply by the reciprocal. So I'm not going to get into that for this, but I think it's really important for you to understand why we do that, because especially, when you're dealing with other problems where it's not so obvious what's going on, it's important for you to understand, why we want to multiply by the reciprocal. But in any way, we're going to follow the same process here. We're going to factor first, and then remember, dividing is the same thing as multiplying by the reciprocal. And I'll just give you an easy example. 2, or let's not do 2. 4 divided by 2 is the same thing as being multiplied by the reciprocal, right? So multiplication by the reciprocal is the same as division. So that's why we can, basically what we do is change this to a multiplication problem by the reciprocal. All right, so in this one we have a is not equal to 1. So again, we got to go ahead and factor that. So we say that's going to be a 2x. This will be an x. It needs to multiply to give you 1. It's a sum, and since the middle term is negative, they both need to be negative. Well, that's kind of nice because I really don't have any options here. They're both going to be a negative 1. Over here, that's going to be an x plus 2. Now, I'm going to rewrite this as x cubed plus 8. So if you remember, that is a sum of 2 cubes. So the sum of 2 cubes can be factored into, if you remember that formula, is going to be x plus 2. So you basically take the cube root of the first 2 terms, and that's going to be times the squaring, so it's x squared, plus the product, minus the product of 2 times x, which is 2x, plus the last term squared, which would be plus 4. Okay, and that formula is usually provided to my students. I don't expect them to memorize it because it is a long formula that's not really used very often. Now we got to go and factor this, which is a perfect square trinomial, because you notice the first term is squared, the last term is squared, and the middle term is double that product. So we can rewrite that as 2x, or you can just factor it in normal ways, which is 2x minus 1 times 2x minus 1. Okay, so now you could go back and do one more step, right, and write this all as 1. But since everything is separated by multiplication here, I can just divide out the 2x minus 1s, and let's see, the x plus 2s. So therefore, my final answer here is going to be x minus 1 times x squared minus 2x plus 4. That looks really bad. Over 2x minus 1. Okay, now on to the ones that trip up the most of us, which is complex fractions. And complex fractions, guys, is basically just a fraction with multiple fractions in it, usually separated by addition or subtraction. So there's a couple ways to go about this. We can apply our operations for adding and subtracting fractions. We could just do that, and once we have it as once we combine these, then we basically have a fraction divided by another fraction, and then you can just go about it that way. And that's perfectly fine, and I have no problem with that. I prefer not to deal with fractions at all. I just don't like fractions. I make mistakes with fractions, so I prefer to get rid of the fractions. And the way to get rid of the fractions is multiply everything, or multiply by the common denominator. Because when we multiply, see here, when we're multiplying by the common denominator, we're multiplying to achieve the common denominator so we can combine the fractions. But if I was to multiply both of these expressions by the common denominator, my denominators would divide into it, and I'd no longer have a denominator. So it's similar, but it's a little bit different operation in thinking. So the first thing we want to do is identify the common denominator of x and x plus 1, which I'm going to state is going to be x times x plus 1. Okay? And now what I'm going to do is, instead of trying to achieve common denominators for all of them, which is one way, I am just going to multiply everything times x plus 1. Now, this does take a little bit more writing, so I will do it for this first one, but I'm not going to do it for the second one. So I'm going to multiply this times every single expression. So therefore, I'll have x times x plus 1 times 1 over x minus 2 over x plus 1 times, let's put that as x times x plus 1, and that's all over x times x plus 1 times 1 over x plus 1. So basically, I'm just applying the division, distributive property here. 2 over x, but it's really important because I really want you to see what is happening here when I multiply everything by the LCD. Okay, so since I'm doing it to everything, it's fine, it's legal. But what's cool about this is now x divides into x. Remember, these are all in the numerator, right? X plus 1 divides into x plus 1. X plus 1 divides into x plus 1. X divides into x. So now my simplified result is I only have one fraction bar now. Now I have x plus 1 times 1, which is just going to be x plus 1. Over here, I have a negative 2 times x, so that's just going to be a negative 2x. Denominator, I have x times 1, which is just x. And then here I have 2 times x plus 1, which is just going to be a 2x plus 2. And now I can just simplify this one more time, combine my like terms. This would be a 1 minus x over, let's do a 3x plus 2. And there you go, done. So by multiplying everything by the LCD, you can just eliminate the fractions. And in my experience, it's a little bit easier than to try to combine fractions and then divide them. All right, so this next one, there's really no rhyme or reason why we have these parentheses, so don't worry about those. I don't like a negative in front. Remember, guys, a negative in front is the same thing as putting a negative in the top or in the bottom. And so typically when you're simplifying, it's best to go ahead and decide where to put that. So I'm just going to put that up top with that 1. Okay. Now, again, first thing we want to do is simplify this. And I see that I can factor this into x plus 3 times x plus 1. All right. And therefore, that's helpful because when identifying my LCD, I just see that these already have that in my denominator. So I'm going to write in the LCD here is just going to be this product of x plus 3 times x plus 1. Okay, so I'm going to do the same process because I like that process. I'm going to multiply everything times x plus 3 times x plus 1. All right, but now I'm just not going to rewrite it out because it takes a lot of writing. Okay, so when I multiply x plus 3 times x plus 1, the x plus 1's divide out, and I'm just going to be left with a x plus 3. When I multiply it over here, I'm going to be left with a negative 2. X plus 3's divide out, so I'll be left with a x plus 1. And then when I multiply it over here, the x plus 3, x plus 1 both divide out, and I'm just left with a negative 1. So let's go ahead and simplify this. Now again, you can rewrite this negative 1, like instead of dividing it, you can rewrite it out in front as a multiplication. So let's go ahead and simplify this so you can distribute those two. So you'd have a negative 2x plus x, which is a negative x. And then negative 2 times 1 is a negative 2 plus 3, which would be a positive 1. And then I can just distribute the negative x. So I'd have an x minus 1. So there you go, ladies and gentlemen. That is basically our operations for complex fractions, multiplying, dividing, adding, subtracting, and then just in general simplifying. And again, a lot of it is good practice to write down the restricted values, which is something we talked in class, but for the sake of time in the live stream, I am just treating them as just expressions without the restricted values. So, all right, so I'm going to take a quick little break, just kind of check into the chat. If you guys want to work on some of these multiple choice questions, then feel free. I will get onto those in just a second. So, just need a nice little break. So, hey, Harvester, and Rob, and Cotton Candy, KBM, Ashman, Francis. Awesome to see you guys here. So let me kind of see if any questions. Harvester, I'm so happy to help you out, man, with your with your pre-calculus. That's what I'm teaching again this year. So we will be getting into, we're going to do rational functions this week and next week, and then we're going to get into the trig. So I'm getting happy to get started into that because I kind of get a little bored doing all the Algebra 2 stuff since I taught Algebra 2 for so many years as well. Cotton Candy, I need help. Well, Cotton Candy, fortunately for you, hopefully I should maybe have an extra 10 minutes. So if you have any questions in general or specific that I can help you out with, feel free to add them to the chat and I'll be happy to help you out. K4B says, hey, can you make these homework sheets and questions with your explain answers available on your website? Thank you very much. They actually are available. I do have them as... I don't offer them though as a free resource, and the reason behind them is, basically I want to communicate with you guys and on these live streams and offer as much value in as far as on the videos. The worksheets right now take a lot of my time when I'm coming, getting home and working on them, and it's really the first time that I've taken all of the stuff that I've done throughout the years and really put them on a sheets. But to answer your question, the reason why I don't offer them as free is because not so much as far as my time, but it costs actually money for me to be able to host the worksheets. I also am needing to be able to afford a editor to come back through those worksheets and, clean them up and fix them. So obviously that's going to be costing money as well. So I try to run a pretty lean website and also math channels. So therefore, if people want free resources, I have a ton of videos for you to help you out with. But there are some things that you just really got to start investing in. And one of those things that I want to start investing in is making some worksheets that, are really high quality, that I can, offer to students and students that, want that additional resources. So that's what I've done. Obviously the students in my class, I just give them the, first rough draft. But what I'm trying to do is, having people that want to support me and then support, my mission as far as in education to, support me on Patreon or support me in the membership. So therefore I can afford those designers. I can afford those editors to really kind of create and help fix up these worksheets. Cause I just don't want to make a mess, of stuff. And sometimes you guys will see on these worksheets, I'll have like mistakes, like right here, like, I have these parentheses I added in here, or sometimes I'll do a typo on the problem. So all that stuff is, I don't have time to go through it all and, fix everything. I got to hire people to be able to do that. So that's why that's why I don't offer them as free, because it is something that I'm investing in, and anybody that wants to help me out with that is more than welcome. However, I'm not going to not help you with your math or do anything else if you don't want to become a supporter on Patreon or on the YouTube channel. All the content is still going to be out there available for you, but I'm hoping that is going to do something. I hope that model, though, can help me out, because I really do enjoy making a lot of these resources. And, I'm hoping that's something that I can continue building out there to offer to you guys. Let's see here. Okay, happy to have you as a Patreon, man, to join. Like I said, just for the resources, it's the same as the YouTube membership, which is, $5 a month. And, currently right now I probably post 40 documents. Let's see, 6 a week. So 24 documents a week. That's like my minimum. That's the base. And then obviously I add cheat sheets and all that other kind of stuff. So if that's something you guys look for, I'd love to have you guys there if you just want to check it out. Obviously I also do private live. I'm looking into doing a private live stream next week for those people. So it's just something else I want to offer a little bit more value for people. But if you guys just enjoy these live streams where I'm going through the work and going through the quizzes, they're going to be going on all year long for free. So don't feel like you have to join one of the memberships. But if it is something you want a little bit extra value from what I'm doing, then feel free to check it out and see if it's right for you. Mala Jack says hi. You want to know, this was my first day. Nice to see you. Good to see you too. Gunter says hi. All right. Algebra 2 play is not helpful for this class, but your pre-calc play is so very helpful for Math 3A. Yeah, I would definitely probably say a lot of the Algebra 2, K4B is a lot of Algebra 2 stuff I have is, maybe be some basic, because I taught standard Algebra 2. I did teach some honors, but, probably a lot of the more advanced problems you're going to see in my pre-calculus curriculum rather than the algebra stuff. Sardeth says hello, and Yvette, graphing polar equations soon. We're not going to get into graphing polar here, Yvette, for a while. So if you have some of those questions, feel free to follow me on my next stream and give me some of those questions. I don't really cover graphing polar. I mean, I cover it, but it's just not very something that is very stressed in my class. So I definitely want to see your example to just kind of work on it and kind of give you some ideas, from there. But all right, guys, let's go ahead and wrap this up here. And again, if you guys have some questions, if I have some extra time, I will be happy to answer kind of some questions on there. So first example is just simplify the complex fraction. So again, what I'm going to do is find the common denominator. So common denominator in this case is going to be 12a. So I'm just going to multiply everything by 12a. Okay, everything times 12a. And the nice thing here is 2a divides into 12a 6 times. So that'd be 6 times 4 minus 3a divides into 12a 4 times. So that's would be 4 times 3. Here 4a divides into 12a 3 times. So that'd be 3 times 1. And a divides into 12a 12 times. So that'd be 12 times 1. Okay, so basically by multiplying by 12a, I eliminated that a and I eliminated all my fractions. Now I just need to do some math to simplify this. So that's a 24 minus 12 over 3 minus 12, which is going to be 12 over a negative 9. And now I can divide, that's a horrible 2. Now I can divide the top and bottom by 3. So I'm getting a negative 4 thirds, which is not an answer choice, so crap. Let's see where I went wrong. Okay, so 2a, that goes into 6 times 4. 3 goes into 12 4 times, that's a negative 4 times 3. 4a goes into that, 4a goes into 12a 3 times 1, and that goes into 12 times 1. Has anybody seen my mistake? Because I'm not seeing my mistake. 6 times 4 is 24. Minus 12 is 12. 3 minus 9 is negative 9. They're not getting a negative either, so something is up. Hopefully somebody found my mistake. I'm going to come back to that at the end. Let's go ahead and work on this one. Let's go ahead and factor this. Nothing I can do here. So a minus 6 over a minus 3. And I'll multiply this here. This gets factored into negative 3 and negative 5. So that'd be a minus 3 times a minus 5 all over a plus 2. So now I can see the a minus 3's will divide out. And I'm left with an a minus 6 and a minus 5. All over a plus 2. So it's not going to be a, it's not going to be c. And now I just need to identify what my restrictions are. Well, I can see that my restrictions a cannot equal 3 and negative 2, which is d. Because even though it got divided out, 3 and negative 2 both make those denominators equal to 0. Right on point for me. Oh, okay. Nobody found my answer yet. What did I do wrong on simplifying this complex fraction? I'll come back to it, but hopefully somebody found it, or somebody can find the answer, or what I did wrong. This one, I got to get common denominators. I see that t squared minus 7 is the same thing as t minus 7 times t plus 7. So I'll multiply this by t plus 7. Okay, looks like they simplified the numerator here, so therefore that's going to be a 6t. 6 times 7 is 42 plus 1 all over my common denominator of t minus 7 times t plus 7. All right, so I should get a 43. Man, what am I? What's the heck's up with this? Oh, 6 times 7 is... No. 6t is a 43 Oh, there it is. I was like, where is 60 plus 40? I can't be making that many mistakes. All right, so that's 60 plus 43. Very good. Oh, and that's it. All right, so anybody else? The geometry should be plus instead of minus. Thank you. Let's see what the heck I made. Oh, good catch. Thank you very much. See how a little simple mistake? There should be a plus. I don't know why I did a minus. So that's a plus. So therefore, this is 12 over 15, which now I can still divide by 3. But when I divide by 3, I'm going to have 4/5, which is answers A. Sir Darth, you're awesome. Thank you so much. I appreciate that. I was like, I don't even know why that negative made sense or where I got that from. Who knows? All right, guys. Well, if you guys have any questions, I'm here for you. Happy to answer any questions. I will let you guys know on a couple things that I'm working on just to kind of see. So if anybody, here's kind of something new, random, that I was thinking about. So I've been looking at like my analytics, and kind of seeing what has kind of been going on. And so one of the things this year that I was doing, which again, I pay for, which is a charge, that I have or account, is doing a lot of like my thumbnail design. Cause obviously I just don't have time to create the thumbnail design. And, one of the things I wanted to do was, I have a lot of videos. So I thought the quick and easy way to do the thumbnails for the videos, was doing the chalkboard and doing the equation. And that's how I've done almost all of my videos. But then I was like, all right, new year, let's go ahead and let's get some design options, and I paid for some design options to look at and to kind of see what's really going to, make my videos more stand out. And so a lot of you guys have seen the like yellow thumbnails, and they have just not been doing very good at all. Like they're actually worse than the black. And there's a couple reasons for that, I believe. One, I think a lot of people that have watched my content are used to seeing the black thumbnail, the chalkboard with the white text. So when they see a different thumbnail, one thing, it might not connect, with them as far as being one of my videos. Or in the same respect, it might be a little too loud, or the equation is not big enough. Or, obviously sometimes it doesn't have like really any kind of artistic, drive into there. So, one of the things I was just kind of looking into that I haven't made any announcements, but for those of you on the live stream, if any of you guys are creatively, astute that maybe want to look into doing some kind of thumbnail design, just privately reach out to me on my channel. I'll be more than happy to maybe have a conversation. I might be looking into, doing some kind of competition, kind of seeing what else people have, because the thumbnails that I got designed just weren't really working, and I'm looking into going to the chalkboard route, which is fine, but I think there's a better option for the thumbnails. And, I think that my thumbnails can improve, where they're just going to look better than just having some equation on a sheet of paper. But either way, it's just something I thought about. So I do see a question from Claudia, says, how do you find the equation of a plane? Linear algebra class, please. Claudia, it has been way too long since I've been in my linear algebra class to give you the proper instruction of writing the equation of a plane. So I apologize. I'm going to have to be able to decline, answer your question. I don't want to attempt to get into something where I'm going to speak incorrectly. Especially it's just been so long since I took linear algebra, and remembering what to do with the planes and how to write those equations. So I apologize. I will tell you one thing I am looking into doing is, going back to a lot of those courses that I took back in the day, in my undergraduate, because I enjoy pre-calculus, I enjoy teaching calculus, I enjoy Algebra 1 and all those, but, I really feel that there's a lot of things that I can expand on my channel, and I would like to, now that I have daughters that are kind of like going to start entering in the school system, I also want to start looking into the curriculum that they're going to get into and start teaching some of that basic stuff and really making sense of it, not only for students that are trying to learn it, but also for teachers and parents, because I think there's a big shift that we need to do in math education as far as how we're expecting people to understand math as well as how we're teaching it. So that is one thing I'm looking into, but, I do apologize. I'm not going to be able to get into that. Kim Wong says, cool math. Kevin says, hi. I got a 4/5. I think the answer is D. Yes. I cannot pronounce your name, but Nakozo, yes, that is correct. 4/5 was the correct answer. And Cameron says, I love your videos. Keep up the good work. Thanks so much, man. Do you have tips on how to improve my math marks? So Hardjap Sendu says, do you have tips to improve my hard math? So, I made a couple of these videos that, haven't really did well, and I didn't really put too much time into them. I just kind of like talked out of them, but this kind of seems as a recurring theme that I'd really like to keep on going at or keep on talking about as far as improving your math. And I think one of the things that the reason why I do these videos for my students is not because I want to give them the answers, not because they can turn them in for a free grade, for a grade and get points, because that's not going to give them the answer. The reason why I go through these is because when I was in school, I didn't have any extra resources. I didn't have the internet to check my answers online. So one of the things I had to do was take the book, look at the 4 example problems the book would give, and I would just work through how they did the problem. I'd look at their work and I'd do it. So what I would recommend is, these resources that I have, or any resources that you have availability to, especially ones where you have the answer. If you understand a little bit, especially once you've just learned something in class, you have all these notes and worked out examples, go home, get an extra sheet of paper out or print out an extra document, blank document, and try to work out the problem yourself. And you're going to get stuck. You're going to forget and not know what to do. So then go back and check the answer, take a peek and oh yeah, that's what I needed to do. So then go back to the problem, finish it, get out a new sheet of paper, and then try to do it again. And you keep on doing that process until you can complete the problem on your own. What that's doing is that's just reinforcing a lot of those skills that you need to do to working through the problem. And it's not very helpful if you don't know if you don't have the answer or the work, right? There's no sense in me giving my students homework if they don't know what they're doing. So I go through these problems and I show them how to do it so they have something to follow. But if you're just going to listen to me or just write down my answers, you're not going to learn. You got to do the work. You got to practice. And so it's best to practice where you have the answers, where you can work off those. So that's definitely one thing I would really recommend to you is, doing a lot of that, practice skills or that deliberate practice to help you out with that. Besides that, guys, I think I'm probably going to enter it up here. It's been 55 minutes. So or not 55 minutes. It's been 40 minutes. So, I really appreciate you guys. Let's see here. Give you guys some updates on my upcoming streams. Today is Tuesday. So I'll probably going to plan on going live again on Thursday. If you guys want to join, we'll look into graphing rational expressions. So we'll get into graphing rational expressions on Thursday, probably looking at the same time as well. So until then, guys, cheers. And happy to have you guys join. All right.